This is problem number 2 of the word problems in the graphing of linear systems. Problem 2 states the sum of two numbers is 13. The larger of the two numbers is one more than triple the smaller number. Part A asks that we write and graph a system of linear equations that represent the sum of these two numbers. So we can begin by saying let x and y be the two numbers. And we should designate one as the larger and one as the smaller. So we'll say let x equal larger number, let y equal the smaller number. Then we can say x plus y equals 13. And now the larger of the two numbers is one more, so that's going to be plus 1. Then triple, that's going to be times 3. The smaller number, that's going to be y. So x is equal to 3 times y plus 1. Because we said x is the larger number, it is one more than triple the smaller number, and that gives us 3y plus 1. Now we have our system, but to solve this by graphing, we're going to need to rewrite these equations into y equals form. So the first one is easy. We just take y equals, and we're going to subtract x to the other side, and we still have the 13. So we see our slope is -1 and our y-intercept is 13. So we can graph that. This second equation, we're going to subtract 1 over to the left-hand side. But now we need to divide everything by 3 so that y is isolated. So y equals 1/3 x minus 1/3. And we have our two equations that we can graph. So the top equation, I'll start at 13, put my point on the y-intercept, and the slope is -1, so it's 1 down and 1 over. And then we'll connect those points. And now the next equation, we start at -1/3, so that's down below. And if I plug in 1 for x, 1/3 times 1 minus 1/3 is 0. And if I plug in 2 for x, so we're going to make a table of values to help us with this one. We have 2/3 minus 1/3, so that gives us 1/3. If we plug in 3 for x, that is 3/3, which is 1, minus 1/3, which is 2/3. And if I plug in 4 for x, that is 4/3 minus 1/3. 4 minus 1 is 3, so it's 3/3, which is 1. So I'm going to use this point 4, 1 as my next point. And you can keep generating a table of values, but now we should be able to pick up that every third point after 4 should be a whole number. So for instance, if we plug in 7 for x, 1/3 times 7 minus 1/3 would be 7/3 minus 1/3, which is 6/3 or 2. And that makes it easier to graph. So every third number over, it'll go up 1 on the y-axis. And now we can connect these points with our straight edge. And it looks like our graph intersects at 10, 3. So let's see if this works. Does 10 and 3 have a sum of 13? It does. And now we want to know if the larger number is equal to 3 times the smaller number plus 1. So is 10 equal to 3 times 3 plus 1? And yes, that's true. So the two numbers are 10 and 3. Okay, so we read the word problem, we wrote our system of equations, we graphed them, we found our intersection point, which is the solution to our system, and then we took that ordered pair 10, 3, and we plugged it into the system to make sure both equations were true. They both must be true for it to be a solution to the system, and we expressed our final answer in written form.